Today we're going to take a look at a package manager called Pixie, which is a system-level package manager available for Linux, Mac, and Windows. The idea is you don't have just a package manager for Python or Rust, you have a package manager that works for multiple languages at the same time and also for system-level dependencies, which means something like FFmpeg or OpenSSL, for example. I found out about this tool at a Rust meetup last week, and I think it's a very interesting tool to take a look at. So if you like this video, let me know by hitting the like button and subscribing. And now let us get right into it. Alright, so we're going to take a look at the Pixie package manager in this video today. This is the GitHub repository. It's an open source package manager written in Rust, which gives it street credibility, of course, and it supports multiple languages and even system level dependencies. So we're not going to talk too much here about the theory. The basic idea is it's based on top, or it's built on top of Conda-Forge. So it has access not only to Python packages, not only to Rust packages, but also to stuff like FFmpeg, OpenSSL, and everything you can find in Conda-Forge. So you can think of this to be a little bit like the UV package manager, but not just focused on Python, but on everything that's needed to get the software running. So you have the same benefits that you have with UV. You have log files, you can have reproducible versions, environments, and everything, but not only limited to Python packages or Rust packages, but to both and also system level packages on top of that. So let's not talk about this for too long. Let's get started. How you install Pixie depends, of course, on your system. I'm using Arch Linux, by the way. Because of this, of course, I have to use pacman. So sudo pacman-s. Pixie is how you install it on Arch. Depending on your operating system, there's going to be a different way to install this, but Pixie is supported on Windows, on Mac, and on Linux on all the different distributions. So just make sure you install it, and then we can basically use it like UV. So if you know how to use UV, you can use Pixie basically in the same way. Let's move to the tutorial directory here. Let's create a sample project. And in the sample project here, I'm going to do Pixie init, which is going to create a Pixie project. By doing Pixie init, what I end up with here is a Pixie TOML file. So here you can see I have basic metadata. I have the author, the channel, which is Conda-Forge, as I mentioned, the name of the project, basic stuff here, and the dependencies, which as of right now are empty. So what I can do now in this project is I can not just install packages, I can also install entire languages. So I can say Pixie add, the same way I can say UV add, but instead of just adding Python packages, I can also add the entire Python version in the first place. So I can say add Python, and then I want to have the version 3.12, for example. So 3.12, and then I can also install Python dependencies in the same go. So I can say pillow, and I can also install, as I mentioned a couple of times already, system level tools. So I can go ahead and say, as a basic example here, the Linux software image magic. So this is a command line tool that I can use to do image manipulation. And this is not a Python dependency, so I cannot just run pip install or UV install to get image magic onto my system, but I can do it with Pixie. If I wanted to do it on a global level here, first of all, I can also use Pixie, but I'm going to talk about this later on. But I can also do this with Arch, of course. I can use pacman to install image magic, but in this case, I only want to do it for this specific project. So I can do Pixie add Python 3.12, pillow, and image magic, which is going to add all these dependencies to the TOML file and also to a log file. So if we take a look at the TOML file, what we will see is that the dependencies are listed here with the constraints. We have Python 3.12 point something, we have pillow, and we have image magic. And what you'll notice now is since I don't have image magic installed on my system in general, if I type magic, which is the command to use it, it says not found. I don't have this tool on my system. However, if I say Pixie run and then magic, then you can see that it actually uses the tool. Of course, it fails because I didn't provide any argument, but you can also see if I say which and then magic, it says not found. And if I say which, or actually Pixie run, which and then magic, then it is happening in this environment. So you can see we have .pixie envs default bin magic. So the tool is installed in this specific project here. And let me show you that this actually works by creating a Python file that is going to use pillow and image magic. So I'm going to copy paste this because this is not a coding tutorial today. This is just a very basic tool that creates an empty image, a rectangle in this image, and then rotates it using magic. What this script does is completely irrelevant. You don't have to focus at all on the functionality. It's completely trivial and useless, but in this case, the important thing is that we're using two things. We're using pillow, this is a Python package, and we're using magic, this is a system level dependency. If we're not doing that, we're not able to run this script. So if I go now and say just Python main py with my ordinary Python installation, it will even tell me that it doesn't have pillow. But even if I run this with UV, if I say UV init, UV add pillow, it won't fail on the pillow dependency, but it will tell me that magic does not exist. So what I have to do here to run it in this environment is I have to say Pixie run Python, which is going to use Python 3.12, the version installed here. And then I have to say main py. So this is going to run it with all the dependencies ready to be used. And you can see if I use Nomax here to show the image, I get this input image, which is very basic. And then I also get the output image, which is with a slight rotation. Nothing fancy. Again, the functionality is not the focus here, but you can see how this essentially works. I can install dependencies on a system level, on a language level, and this is not only useful if you want to use a package that you don't have, this is also useful if you want to use the same package in different projects with different versions. So ffmpeg is a tool I have on my system, but I can also install it using Pixie with a different version. So we can see what happens if I say Pixie add ffmpeg, and also maybe we want to add OpenSSL or something like this. This is now going to be added. And if I say which ffmpeg like this, you can see user bin ffmpeg. And if I say Pixie run which ffmpeg, it's a different version. And maybe it will actually be a different version. I'm not sure about this. So maybe if I say ffmpeg version, actually it doesn't know that. So maybe it's just -v, or it doesn't have a flag like this at all. So let me just run ffmpeg, and you can see it's 8.1.1. And if I now say Pixie run ffmpeg, it's also that, but without the end. So I think that's a nightly version, I'm not sure, but both are up to date. But the idea is I can also pin the version to be a specific one. So for example, I can say Pixie add and then ffmpeg equals 7. So that will install version 7. And then if I say Pixie run ffmpeg, we're going to see that I'm using a different version now here in this particular project. But if I just run ffmpeg, it's running still my 8.1.1 version on the system level. Now, maybe just a quick mention of the log file. So the idea with log files and toml files is that in the toml file, you have the basic constraints, the basic definitions. These dependencies have to be resolved in a way that everything is coherent and consistent, but the log file is then the actual thing that you get. So the log file is the concrete package versions of everything exactly, not just as constraints. And when someone takes your log file and then uses exactly the same versions, they have the same environment. Not as reproducible as a Docker container, but getting closer to it because you're also using system level packages. Now, a second thing that you can easily do with Pixie is you can code Python extensions in Rust, or you can also call them Rust extensions for Python. And this works with a single package manager. You don't need cargo, you don't need UV, you don't need pip. You can just use Pixie for everything. And we're going to do that here. I'm going to say Rust example is going to be my directory. I'm going to go in here. I'm going to create a Pixie project, Pixie init. And now we're going to install both Python and Rust. We're also going to install pip, and we're going to install Maturin, which is for building the extension. So I'm going to say Pixie add Python is equal to 3.12. I'm going to install Rust. I'm going to install pip, and I'm going to install Maturin. And as you can see, that's all I need. No cargo, no pip. I mean, technically I'm using pip, of course, but I'm not using pip separately myself. I'm doing everything via Pixie here. And now I can just run Maturin as a tool. So Pixie Maturin, then init. The bindings here are going to be py03. And the name of my extension will be, I don't know, Pixie Rust extension or something. And of course, you cannot just say Pixie Maturin. You need to say Pixie run Maturin for this to work. So now we have our project set up. You can see we have a cargo toml, we have a PyProject toml, we have everything we need. And now we can go into the source file. Here we have our extension. I don't have syntax highlighting for Rust right now, but basically this is the code for the default extension. I'm going to just replace this with code I prepared. Very, very simple. Now I think I need to rename this because now I called this Pixie Rust extension, not Pixie Rust or Pixie Py Rust. So we need to make sure that this is consistent here, but we only have a simple function, double. It takes an integer and returns the integer times 2. Nothing fancy, wrapping this as a Python function. That is our Rust extension. And all we need to do now is we need to run Pixie run Maturin develop in the correct directory. So in the Rust extension example directory here. And then all of this is also installed automatically into the correct Pixie environment that we're working in. So we don't have to somehow manually install the package in a VM for something. And I can create a main py file now, and I can say import, and I call this Pixie Rust extension. And I can just print the result of using Pixie Rust extension double, and then a number like 20, for example. And then all we have to do is Pixie run Python main py. And there you go, it works. So we didn't have to use cargo, we didn't have to manually use pip. Both of them were used behind the scenes, but we used Pixie for Rust and Python, one package manager for both of them. And also, of course, if you need system level dependencies here, that would also be part of the project. You can just add ffmpeg here, use it in Rust, use it in Python, whatever, and everything would be managed using Pixie, and you would also have everything fixed in the log file. So yeah, that's basically what I wanted to show you here. I encountered this package manager last week at a Rust meetup, as I mentioned in the introduction, usually not the language that I work with a lot. Maybe this will change in the future. But I found this to be a very interesting and useful tool because you just have to use a single package manager for everything, and you have a somewhat reproducible environment, more so than when just using UV, because UV can depend on the exact package versions in Python, but not on ffmpeg, for example. Now, maybe one last thing that I want to show you, just a little trick. If you have sometimes very long commands like Pixie run, and then you have, I don't know, Python main py, and then a couple of flags, you can register this as a command. Or in Pixie, it's called task. So we can say Pixie task at, and then we can specify what the command is. So let's call this one start main, and the code for this, or the command for this, will be Python main py. In this case, not a very fancy one, just 2 arguments, argument 0, argument 1. But now what I can do is I can say Pixie run and then start main, and that will run Python main py. And of course, if this is a longer command, this is quite convenient because you just have to type the name of the functionality. And now the very last thing that I want to mention here is that there is also an option to install stuff globally, but on Arch at least, I don't think that this is recommended because you should rely on Pacman and the AUR helpers like Yay to manage everything, and you should not be messing around with global installations with a different package manager. This is just an Arch thing, but you can also install packages globally using Pixie. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, in case you're interested, on my website, you will find a services tab and a tutoring tab. There you can contact me if you need help with a project, if you need a freelancer, a consultant, whatever you want to call it. You can contact me via LinkedIn or email at the bottom of the pages. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.